You're watching the Weiss channel. Thank you very much. I'll be here all week. Today we're going to do simplifying rational expressions. All right? And it's going to be the same concept as when we multiplied last week. Okay? So, remember a problem like this? And what I suggested we do first was do this parenthesis thing first. So I'm going to do that. I'm going to say we got 3a squared b c to the fourth times, you take 2 to the third, right? 2 to the third is 8. A to the 1 times 3, that's a to the third. B to the 2 times 3, that's 6. And c to the 3 times 3, that's 9. Now we put it all together. 3 times 8 is 24. But a to the second times a to the third, remember we add the exponents, right? A to the fifth. B, this is b to the first, right? B to the first times b to the sixth is b to the seventh. Very good. C to the fourth times c to the ninth is c to the 13th. Okay, and that's how you simplify when you're multiplying. But today we're essentially going to divide. Okay? For example, 8a to the 7th, b to the 9th, c to the 8th, divided by 2a to the 3rd, b, c squared. All right? Again, don't change the laws of math. 8 divided by 2 is still 4. Okay? But this time, instead of adding the exponents, because we add the exponents when we multiply. When we divide with exponents, we subtract the exponents. In fact, let's do this one time. I'm going to do 8. This 8 to the 7th is 1, 2, 3, 4, 5, 6, 7. B to the 9th is, wait a minute, time out. I'm going to do over here. 8. 1, 2, 3, 4, 5, 6, 7. B to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. C to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. All over. 2, a to the third. 1, 2, 3. B, and then c to the second. So what's happening here? Well, the 8 and the 2 cancel, right? 2 goes into 2 once, 2 goes into 8 4 times. And then, how many a's cancel? 1, 2, 3. 1, 2, 3. How many b's cancel? Just 1. And how many c's cancel? 2. 1, 2. 1, 2. So now, what's left? Well, the 4. How many a's are left?
4.
1, 2, 3, 4, right? 7 minus 3 is 4. So we say a to the 4th. Right? And then what's b to the 9 minus 1? 1, 2, 3, 4, 5, 6, 7, 8, right? B to the 8th. C to the 8th divided by c to the 2nd, how many c's are left? 1, 2, 3, 4, 5, 6. C to the 6th. And that's how you simplify rational expressions. Okay? So, let's do the same thing here. Okay? 3d squared e f to the third over 15d to the 7th e to the 4th f to the 9th. Now, here's what we're going to do. We're going to say, all right, 3/15 reduces. 3 goes into 3 how many times? 1. 3 goes into 15 how many times? 5. Okay. So we have 1 over 5. I'm going to put the 5 on the bottom. Okay. D to the second over d to the 7th. All right. How many d's are left when you subtract 7 minus 2? 5. But are there 5 d's on the bottom or are they on the top? They're on the bottom. Does that make sense? Does it make sense that d to the 5th is down here? Nod your head if that makes sense. Are we okay with that? Okay, wait a minute. Okay, let me do this. I'm going to change that.
It matters.
Yes, it matters. Let's do this. We've got 3, D, D, E, F, F, F. Okay, all right. Okay, and now we have 15. We have 1, 2, 3, 4, 5, 6, 7. 4 E's. 1, 2, 3, 4. And 9 F's. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's what's happening. What's happening is this. The 3 and the 15 cancel. 3 goes into 3 once. 3 goes into 15 5 times. How many D's cancel? 2, right? How many D's are left? 1, 2, 3, 4, 5 on the bottom, right? Do you see what's happening here? All right. And then, how many E's cancel? 1. How many are left? 3 on the bottom, right? And how many F's cancel? 3. 1, 2, 3. 1, 2, 3. How many F's are left? 6, but on the bottom, right? Nod your head if that made some more sense. Okay? So here's what's happening here. Everything got canceled on top. So what do we leave on top? A 1. We leave a 1 on top. On the bottom is 5. How many D's? There's 1, 2, 3, 4, 5 D's. Okay? How many E's are left? You have 4 on the bottom and 1 on top. You're left with 3 on the bottom, right? How many F's are left? 6 on the bottom. F to the 6th. Are you okay with that? No?
So basically, like, whatever exponent is higher.
Yes! That is outstanding, Nishadi. So what's happening is, wherever the exponent is higher, that's where the variable is going to stay. Okay? Over here, all of the exponents were higher on top. So all the letters stayed on top and there was nothing on the bottom. Over here, all the exponents were higher on the bottom, so they all stayed on the bottom, and only a 1 was left on top. Let's see if this next one makes sense, and hopefully it will make the whole thing make more sense. Okay? 36 and 16. What number goes into both 36 and 16? 4. How many times does 4 go into 36? 9 times. How many times does 4 go into 16? 4 times. So we've got 9 over 4. Now, here's g to the 4th, here's g to the 5th. What's 5 minus 4? 1, right? Now, is g to the 1st going to be on the top or on the bottom? It's on the bottom because more g, after all the g's cancel out, there's 1 left on the bottom, right? Because the higher g is on the bottom. Over here, you have h to the 27th on top and h to the 6th on the bottom. What's 27 minus 6? 21, right? So 21, is it going to be on the top or is it going to be on the bottom? This one's on the top because the higher exponent was on the top. Okay? K to the second over k to the seventh. 7 minus 2 is 5. But will it be on the top or on the bottom? On the bottom, because the higher exponent is on the bottom. And that's how you do this problem. Is that making more sense?
Yeah.
Okay. Over here, 14 and 22. What number goes into both 14 and 22? 2. 2 goes into 14 7 times. 2 goes into 22 11 times. So you have 7 over 11. M to the fifth over m to the fourth, and m to the first leaves you with m to the fourth. Is it on top or on the bottom? On the top, right? N to the first over n to the third leaves you with n to the second. But is it on the top or on the bottom? On the bottom. P to the eighth over p to the fifth leaves you with p to the third on top. That's how you do these problems. You've been watching the Weiss channel. Da 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 da.